On today's video, we're going to build and try out ZuluSCSI Pico Community Edition, an open source project for connecting SD cards to vintage PCs and Macs, instead of mechanical hard drives. We have previously tried out one of its predecessor, the SCSI 2SD, in an IBM PS2 Model 50, and we have built and tried out Blue SCSI in a Mac Color Classic. The main goal for this project is to try different cards and find out how compatible they are with different systems, and which ones are the fastest. Before we start soldering, we need to unbox a new toy. So this is a Tomlov digital microscope, the TM4K-AF Flex. And a full disclaimer, this was sent in for free. So first we have the manual, and then we have a microscope with the built-in display. Okay, and they have added two LED lights on the microscope. On my old scope they are installed on the base plate. But this guy here doesn't have a base plate, as you will see in a minute. When it comes to microscope, lighting is everything. Another obvious added feature here is the autofocus function. My old microscope here is fully manual. Manual focus works really well for soldering electronics, but this is definitely going to come in handy, especially when you inspect boards. I guess we'll start by peeling this off. Okay, we've got a remote control, cleaning cloth, a USB-C cable, and what I think is an HDMI cable. Then I actually got two power supplies, but this is probably a YouTuber's thing. You'll probably only get one power supply for your region. Next up we have a holder, I think. Yeah, it looks very similar to the old one. And underneath here we've got the main benefits of this microscope, the flex arm. And this is one of the main benefits of this microscope for me. Since the old microscope is on a stand, I have to store it away when I'm done, and then I have to go and grab it next time I need to use it. But this guy here can stay permanently on the bench. So really neat time saver. Then we have the mounting bracket here, of course. And the last thing down here is a silicone mat. I've been wanting to try one of these out for a while, so it's really nice of them to include one. The tools to assemble it were included, so that only took a minute. And the clamp is adjustable, so it can be used with really thick, sturdy benches, or a skinny and flimsy one like mine. The flex arm also has some plastic bits here for cable management, so that's really neat. And it is quite well designed, so the microscope doesn't change angle as you move it up and down. So how about that autofocus? So if we move in real close. Okay, it takes about 4 seconds to refocus. Okay, great, so let's start building the card. And to make this video possible, we're going to need some help from the sponsor of this video, PCBWay. Thank you PCBWay for supporting this channel. And in here, we've got some PCBs, of course. Let's move in closer. Okay, so let's have a look at these. And see what PCBWay sent us. Really well packed, as always. And as expected, these PCBs look awesome. I was a bit concerned about the length of the arm, but it turns out it's perfect. So it's long enough to reach where I want to work, and also long enough so I can push it away when I don't use it. And this project has an interactive bill of material online. These are great, they make it so much quicker and easier to build one of these boards. So on the first row here, we've got a bunch of 100 nanofarad 0603 caps. And these are tiny little buggers. Without the microscope you would just see a dot. So let's add some flux. And I'll put a splash of solder on the tip. And then we'll add the cap and solder it to the board. This is pretty easy with a microscope. And then we can just add a splash of solder on the other side. And for these tiny little guys, I'm using my hook tip. Now let's remove that flux and check. Unfortunately my bench is really flimsy So I hope this is not going to be too shaky. I definitely need to get a new bench. Yeah, that is looking good. Now let's check that autofocus, because here is where I think it's going to come in really handy. That actually doesn't look too good. So we've got a big splash of solder on one side, and the other side isn't sitting flush on the board. But looking from above, it looks pretty good. Now this doesn't really matter, of course. We could leave it like this, but I like to keep things neat. So I'll just reflow both sides and push that cap down. Now let's check again. That looks much better. So I did a very similar project quite recently with the ZuluSCSI. So in this video I'm going to skip quite a bit. And if you want to watch the build more in detail, then check out that video. I'll leave a link in the description. And in this video I'm going to move quite quickly. Well, this is a bit embarrassing. I'm just finishing the first row of caps here, and I just realized I don't like autofocus. I prefer manual focus, because as I move around on the board, the autofocus works as it should, but I just don't like it. That's probably just a habit, so I can't really explain why. I just prefer manual focus. I guess this is probably just because I'm used to it. When I make my videos, I shoot everything in manual focus. And when it comes to photography, I actually still shoot film. So most of my cameras are actually manual focus only. And I guess that's just how I prefer things. But I still really like this microscope. Love that arm and the lighting. It's great. I guess I'll ask nicely, and maybe they have a manual focus version of this microscope. The silicone mat is great, by the way. It has these small compartments where I can keep all the tiny little resistors and caps. If I put them on the bench or my cutting mat, they are really hard to see, but not on this rubber mat. They are clearly visible and easy to find. Okay, and here is where things didn't go as planned. So first I got the stupid man flu, so I took a few days off to feel sorry for myself. And then I decided to assemble the rest of the card off camera. And then I spent a few of my precious evenings just troubleshooting this card. So first of all, I forgot to order these 2.2 mH inductors. Not a super common component, so it took a while to find one on my scrapboards. And apparently one of my floppy drives had one. It's a through-hole component, so I had to bodge it on the pads. I will order some, of course, and replace it later. But the card obviously didn't work. So first I checked my soldering, and then I checked that I had put the correct components on the correct pads. And then I checked the direction of all the ICs and diodes. But I couldn't find any faults, and the card still wouldn't work. So then I suspected my Pico, because it looks a bit different. So I got this one here from Mouser for the ZuluSCSI card. And as you can see, this guy here looks a bit different. I bought it on AliExpress, but it was advertised as a genuine part. But as you can see, it doesn't have the logo at this end of the card. So I figured maybe it was a fake. But it actually says Raspberry Pi Pico in the silk screen here. And underneath here, the Mouser part is version 2.14. And the Pico from AliExpress is 2.22. So maybe it's supposed to look a bit different. Or perhaps it is a fake. I honestly couldn't tell. In any case, I installed the Pico from my ZuluSCSI because we know it works. But the card still wouldn't work. And I finally found the issue. It's a stupid compatibility issue with the SD cards. I have this expensive Samsung card installed. It's a Samsung Pro Endurance. Pretty expensive card if I remember correctly. I also tried this Kingston here. This guy here is a Kingston microSD HC1. And then I finally tried with this card here, and the damn card works. The reason why I didn't try with a different SD card earlier on is because I have this guy here installed in the ZuluSCSI and it worked. But for whatever reason, it doesn't seem to play well with the ZuluSCSI. I kind of thought it only had to be compatible with the Raspberry Pi, but apparently there is more to it. Well, in any case, the card finally works with this SD card here. I couldn't find this exact card on Amazon, but I have ordered something very similar, just slightly newer. So we're gonna try those cards too, in ZuluSCSI. Actually ended up building 2 of these, since I couldn't find a fault on the first card. I also reinstalled the Pico Pi I got from AliExpress, and it works just fine. Genuine or not. And there isn't really much to say about the assembly, it was very similar to the blue SCSI. It does have an interesting feature here I haven't seen before. It has pads for pin headers here for an external SD card. That could be really useful, since having the SD card outside of the machine is of course really handy. So I'm gonna try and see if I can find one of those SD card holders. And we'll try it out in a future video too. There are extension cables you could plug into the SD card holder, but this is probably a better solution. Now, I'm not a big fan of 0603 components, so if you have some KiCad skills, you could replace them with something larger before you order your PCBs. And if you do, I would also consider moving these 2 caps down here and put them in one row here, because they're a bit hard to reach when soldering, especially with the SD card installed. Also pay attention to this guy here, because it's installed reversed, so it's really easy to install it backwards. But aside from that, the card was really straightforward to build, so I don't really have any complaints at all. This is a great project. And about the microscope, after having used it for a project, I noticed that the higher resolution makes a huge difference. I didn't think it would, but you get so much more details when you inspect solder joints compared to my old microscope. So that was a rather unexpected and really nice feature. By the way, I also installed the optional speaker here and this optional jumper. So I get clicky noises that indicates the system reading from the SD card, sort of similar to hard drive clicks. So with these 2 SD cards, the LED flashed 5 times, and that means it couldn't find an image file on the SD card. Now the strange thing is that one of these cards gave me 5 slow clicks, and the other card gave me 5 very fast clicks, but I couldn't find anything about the difference online. By the way, the firmware page refers to the ZuluSCSI Pico bin file, but I couldn't make it work, so I had to use the UF2 file instead, and that worked. I found a random image file online with DOS622 installed on it. Placed it on the SD card and renamed it to HD6. And here it is in our system now, hard disk at ID 6. I will create a custom image file for this machine later. So if we turn the machine on without the ref disk in the drive, the tiny little speaker is making some clicky noises, and the machine boots to DOS. So this card can do about 10 megs per second, and I think that's roughly the limitation of the Spock card too. So this is a pretty good match. I'm ordering yet another card, and we're going to try all 3 in different projects as we record them. But for now, let's at least try one more machine with this card. Let's try with the Model 50 here. These machines are not compatible with the Spock. Instead, this machine has a future domain MCS350. And this card works with a different ID, so I had to rename the image file on the SD card to HD0 instead of HD6. That's how the ZuluSCSI knows which ID to use. So let's give this a try. Okay, it found the ZuluSCSI hard drive at ID 0. So this is looking good, but then unfortunately it hanged. So let's try with the ref disk. Well, it hanged again, but apparently that was a bad diskette. So let's go to set configuration. Okay, and we seem to have an issue with the future domain card. In that case, let's go back and copy an option diskette. Remove that ref disk and install a diskette with the ADF files for the future domain card. And then switch back to the ref disk again. Okay, so apparently you have a newer version of the ADF files on the ref disk already. So that was strange. Why did we get an error? I'll reboot and check. And this time with a DOS diskette instead. Now, just realized this could be an issue with the hard drive being too large for the future domain card. But before we try with a smaller image file, let's try F-disk MBR and reboot the machine without the DOS diskette. I think we've had some issues with drives too large for that card before in other projects, so I think that's the most likely thing to be an issue here. Okay, and it still doesn't boot. Okay, let's try with a smaller image file. To create a blank image file in Windows, we need to use this command here. And HD00 is the name of the file. It has to start with HD, and the number after HD has to be the SCSI ID. In this case, it needs to be 0. And then we have the size of the image file. In this case, it's going to be roughly 100 megs. And here's our new file, HD00, 104 megs large. And place the copy on the SD card. Now let's boot with the DOS diskette in the drive. Okay, let's try F-disk. Wow, this is looking good. So let's check, no partitions defined. So create primary partition and reboot. Now let's try to format that partition. Sure, I'm sure. Formatting 102 megs. Format complete. It makes rather funny clicky noises. Not exactly like a hard drive, but I guess not too far off either. Okay, let's check that drive next. Okay, it is recognized by DOS. Now let's try and see if it will boot. By the way, the clicky noises can be turned off by removing this jumper here. Oh, and it boots! Awesome! So it is compatible with the future domain card in a Model 50. This is looking pretty good for this project. I spent some time on Google to see if I can find what machines this card was compatible with, but I found absolutely nothing. But now at least we know it's compatible with a Model 80 and a Model 50. Well, since we have it on the bench, I think we should try it with a ZuluSCSI, because the Model 50 project is kind of finished. So I'm not sure if this machine is going to return in any other videos. Okay, using the same SD card. Let's see if this works. No SCSI drive found. Check cables. Okay, so the ZuluSCSI doesn't work in the Model 50. Well, then we know. So if you have a Model 50, your options are the ZuluSCSI, or the SCSI 2SD, or the MCID. The MCID is the best option, but it's also the most expensive. And it is the best option because it can be installed inside the drive bay and doesn't take up one of the precious MCA slots. I say precious because this machine only has 3 of them. Well, since we tried the ZuluSCSI in the Model 50, we might as well try it in the Model 80 too. So, using the same SD card, let's turn this machine on and see how it behaves. And unfortunately no, it's not recognized by the system. This here is the missing ZuluSCSI. And the drive down here is the CD-ROM drive. Okay, so that didn't work, but how about that fancy Samsung card? By the way, the ZuluSCSI here is tested in a color classic. I still have the hard drive connected to power, so that is why we're getting some SCSI noises in the background. But it's not connected to the SCSI bus. And unfortunately no, it's not recognized by the system with the Samsung card either. Well, I'm gonna say this video is a big win for the ZuluSCSI. And this project is unfolding as I kind of thought it would. This is going to be a lot more about compatibility than speed. And with that being said, I am actually ordering parts for a much faster card. And although I don't think there are many machines that will take advantage of the higher speed, I think I have at least 3 that will. So I hope that card is compatible, but we will know in a few weeks. So I'm going to end this video by saying a huge thank you to PCB Way for sending in the PCBs, and to Tom Love for sending in the microscope. And last but not least, my patrons. Thank you guys for being patient during November. This month has been rough. I've started recording no less than 6 different videos, but only managed to finish 1. So let's hope for a really nice and smooth December. But that's all I had for today. Before you leave, like, subscribe and leave a comment, and consider joining me on Patreon. Thank you for watching, and I'll see you guys again next week.